Welcome to this lesson. We're going to continue with the Nyakkima Joint Examination 2025 Mathematics Paper 2. The section 1 has already been uploaded in this channel, so please take your time to search at Shifting Grades Online School, Nyakkima Joint Examination Paper 2, Section 1. Then we are continuing with part of the Section 2, whereby we shall be beginning at number 21. A question on matrices and transformations. So please feel free to invite a friend to this broadcast. Just share the link with them. Remember, our consultation line remains 07 04 15 33 66. So please engage us, and you're going to benefit from our programs. Let me remind you of our program here for the holidays, the April holiday, whereby high school students are supposed to call us or WhatsApp or SMS 0704 153366 for a serious engagement, whereby we're going to offer interactive lessons, interactive sessions for the sciences and mathematics through Google Meet. So please feel free to join us. Also remember our program here, whereby you can purchase airtime for any line from your M-Pesa by just going to your M-Pesa, the Lipa na M-Pesa option. Then the pay bill number is 737356 account, the phone number that you're purchasing the airtime for. Then after that, now you enter the amount that you'd like to spend, complete the transaction, and you shall receive the airtime instantly. Remember, you can also purchase a friend, whereby you go to the pay bill number 737356 account number, the friend's number that you'd like to load airtime to. After that, the friend will receive the airtime instantly. Utilize this facility and also invite your friends to the same. Back to the paper now. Number 21, a quadrilateral ABCD has vertices A for negative 4B to negative 4C, 6 negative 6, and 4 negative 2 for D. On the grid provided, draw the quadrilateral. A quadrilateral is a four-sided figure. The axes have already been labeled for us. So ours is to directly go into the plotting. So A is 4 negative 4. So 4 negative 4. This is where we will have our A. Then B, coordinate B is 2 negative 4. So 2 negative 4. This is where B is. Then C is a negative 6. Okay, 6 negative 6. So C shall be here. And finally, we have D. Coordinate D is a 4 negative 2. So 4 negative 2. At this point, we're going to have our D. At this point, we're going to have our D. So now we have to connect all the vertices for us to get the quadrilateral. And a good reminder is that you join the vertices as they have been named. So you don't connect them anyhowly. If it's A, should be connected to B. Then B should be connected to C. Then C to D. So you don't just connect whatever is close to one another. So from B now we come to C. Then from C, we go to D. And from D, we come back to A. That's how you should be having the diagram. All right, in part B, we are told the A prime, B prime, C prime, D prime is the image of ABCD and a positive quarter turn about the origin. Origin becomes now the center of the rotation. Then when you talk about positive quarter turn, that's a rotation, and a quarter is 90. So when we talk of positive, a quarter, it means positive 90 degrees. When an angle is measured in the positive direction, it means anti-clockwise. Anti-clockwise. So 90 degrees in the anti-clockwise direction. We're supposed to connect every coordinate to the center of rotation. Then we measure 90 degrees in the anti-clockwise direction. Therefore, we connect A to the center. Then we measure 90 degrees and an equal distance on that side. So an equal distance will take us to a point like this, and we will have arrived at A. So this is A prime. Then for C, we do the same. We connect C to the center of the rotation. Then we move an equal distance after measuring 90. After measuring 90, we move an equal distance so that we get C prime that way. Then after C prime, we can do the same for D and also for B. So we join B to the center. We join B to the center. That way. Then after that, we're supposed to measure 90, then we move an equal distance to the opposite side. So we measure 90 and we move along that for an equal distance at this point now. This is D prime. Then finally, there's B, whereby we are joining B to the center. Yeah, B to the center that way. Then we measure 90 degrees and we move for an equal distance. So this is how we're going to do it. After measuring 90 degrees, we shall move to a point like that, whereby this now becomes B prime. Then we are supposed now to connect from A prime to B prime, then from B prime to C prime, then from a C prime to D prime, then back to A, then back to A. That way. So we are having the first contralateral together with its image after a rotation about the origin, positive 90 degrees. That is how we rotate. Yeah, that's how we rotate it. Then after this, now we check part B of this question. The question says that A, B, C, D. That one is done, sorry. Then now part C now, that was B. And remember in B, we were supposed to write the coordinates. So A prime is becoming 4, 4. B prime, we list the coordinate 4, 2. C prime, as can be seen there, 6, 6. Then D prime is going to be 2, 4. Good. Look at part C now. A double prime, B double prime, C double prime, D double prime is the image of A prime, B prime, C prime, D prime under the transformation given by the matrix 1, -2, 0, 1, as you can see. So we know that matrix of transformation multiplied by image, multiplied by object, we should get the image. Therefore, we write the matrix first. That way. Then we multiply this by, if it's A, it's 4, 4. Then B is 4, 2. Then C is 6, 2. Then when we talk about D now, we are having 2, 4. So that we get the image. So the image is going to be, we're supposed to multiply matrices this way. So 1 by 4, negative 2 by 4. That will be 4 minus 8, negative 4. Then we go to the next, whereby it's 1 by 4 and negative 2 by 2. So it will be 4 minus 4, giving us a 0. Then the next shall be, go to this column now, whereby we talk about 1 by 6, negative 2 by 2. So 6 minus 4, giving us a positive 2. And finally, we are talking about the same row by the last column here, whereby we'll be having 1 by 2 and negative 2 by 4. That's 2 minus 8, giving us a negative 6 that way. Then on the lower row now, we'll get it by, we come to this row times the first column, 0 by 4 and 1 by 4, giving us 4. 0 by 4 and 1 by 2, giving us 2. 0 by 6 and 1 by 2, giving us 2. 0 by 2 and 1 by 4, giving us 4. That is how we get all of them. After this, now you can list the coordinates, because we were to determine coordinates. A double prime is going to be negative 4, 4. B double prime, 0, 2. C double prime, 2, 2. And D, actually, for, let's see C double prime. I think we can, C double prime, we need to confirm this coordinate. You know, this was a prime, B prime, C prime, and D prime. So this was supposed to be 6, 6, according to the coordinate here. So with 6, 6 now, we are talking of 1 by 6 and negative 2. And negative 2 by 6. That will be 6 minus 12, giving us a negative 6. So we should be having a negative 6 at this point. Then now on the lower side, we'll be having a positive 6. Yeah, that way, positive 6. So for C, the coordinate is supposed to be negative 6, 6. Then for D, double prime, we state it as negative 6, 4, that way. Then we are supposed to plot it also on the same grid. Draw the contralateral. Draw the contralateral. So negative 4, 4. Negative 4, 4 is the coordinate at this point. That's our A. Then B is 0, 2. So 0, 2 should be here. This is where B is going to be. Then C is supposed to be negative 6, 6. Negative 6, 6 supposed to be here. Remember, it's double image. Then finally, D is supposed to be negative 6, 4. So negative 6, 4 is at this point. So with this now, we can connect until we come up with last image now. So A to B, then B to C, then C to B, and back to A, back to A, that way, and back to A. So this is now the last image. After this, we are being instructed to determine a single matrix that would map the first contralateral into the last one. So a known matrix, which we can give it some coordinates like A, B, C, D. Those are the elements in the known matrix. Then we are multiplying matrix. We are multiplying A, B, C, D, which is coordinate 4, -4, 2, -4, 6, -6, and 4, -2, for us to get the final triangle, which we've just dealt with up there. -4, 4, 0, 2, -6, 6, -6, 4. That way. So it is the matrix which is not known in this particular case. And we are able to get it. According to the multiplication of matrices, we know that if this row is multiplied by the first column here, it will give us the first element in the answer matrix. Therefore, 4 by A, 4A, -4 by B should give us -4. Then, if we go to the next, such that the same row by the next column here, we're supposed to get a 0. Therefore, 2 by A, then -4 by B, this is supposed to give us 0. With this, we can eliminate, let's use elimination. We can eliminate B because the coefficients of B are equal in both equations. So 4 minus 0, get a -4. Then -4B minus -4B, that one cancels to a 0. 4A minus 2A will give us a 2A. Therefore, the value of A simplifies to -2. Now that we've gotten the value of A, we can solve for B and say that for B, we need to use the second equation or even the first one. So we need to say in the second equation, 2 by -2 minus 4B equals to 0. So that -4 equals to 4B. The value of B shall be -1. So we have A and B now. Let's pick some other pair of equations so that we may solve them using C and D now. So using this row times the first column, we will have 4C and -4 by D being equal to the first element here, which is a 4. Then we also go by the first row, the second row here, CD, and the second column to -4, where we have 2C minus 4D to give us the next element, which is a 2. So we can again eliminate D by subtracting. 4 minus 2 is 2, -4D minus a -4D, that one becomes a 0. Then 4C minus 2C becomes 2C, so that the value of C is 1. If the value of C is 1, then that of D can be found very conveniently by saying in the first equation, or even in the second, we can substitute anywhere. We can use the first equation or the second. Let me use the first. 4 times C, which is 1, minus 4 by D equals to 4. So this is going to be 4 minus 4, giving us 0. -4D equals to 4, which means the -4D equals to 0, which means the value of D is 0. Now that we have all the elements, then the matrix can be expressed. The matrix will be A, -2, B, -1, C, 1, and D, 0. So we are having the matrix there of transformation responsible for that mapping. All right. After this, now we can check number 22, a question on angles, tangents, circles, and chords. Number 22. In the figure below, AD equals to 28. That is the diameter of the circle. Then the center is O. TCS is a tangent to the circle at point C, as you can see. Then AB is the same as BC. So AB and BC are equal lines. Then the angle at A is 32, as you can see. Giving reasons find the size of the following angles. ACS, this particular angle. So let's look at how to find such an angle. We know that DA is a radius, is a diameter. So diameter subtends an angle of 90 at the circumference. If that is 90 and we have that 2 at that other point, then following the principle about angles inside a triangle, we can conclude that this is 58 because we need to add 58, 32, and 90 for us to get the full angles inside this triangle. If that is so now, we can use a principle here which will help us to argue that the value of ACS is the same as CDA, which is equal to 58 degrees. Reason being, angle subtended by a chord and a tangent is equal to angle in the alternate segment by the same chord. Angle subtended in the alternate segment by the same chord. So if the chord CA is producing an angle of 58 at the circumference, then the same chord AC is supposed to leave an angle equivalent to 58 with the tangent. That is something you should know. And through that, we can also argue very quickly that this one is also 32 degrees because DC is the one producing 32, and therefore DC is supposed to make an angle of 32, an equivalent angle with the tangent. That way. Good. Now we proceed to the next. The angle here that we are finding is DOC, and we are finding the reflex one, DOC. So we can have the angle drawn here, DOC. So we need the reflex one anyway. This one. That is the reflex angle that we need, DOC. So let's get the acute one first. It's good for you to remember this, that DO and OC are both radi to the circle, which means this portion of the angle is also 58. So we will have DOC as what you call isosceles triangle, making the base angles to be equal. That means we can get the angle at the center of the circle, whereby we need 180 minus 58 and 58 that way. So now we talk about 180 minus 58 and 58, giving us exactly 64. But now the angle that we need is the reflex one, which means we have to get DOC, the reflex angle, by taking 360 minus 64. So when we take 360 minus 64, we'll get 296 degrees. Angle at a point. They must add up to 360. That is the main reason we have calculated the value of the angle, you see, that way. We also have another angle here that we've been instructed to calculate. The angle is BCS. The angle BCS. So BCS is the angle, the small angle at this point. BCS, the small angle at that point. Now we are supposed to get the angle using several approaches. One, we can use opposite angles in a cyclic contralateral. We know that ABCD is a cyclic contralateral, and a cyclic contralateral is a contralateral whereby the vertices therein, all of them touch the circumference of the circle. Therefore, if we talk about opposite angles in a cyclic contralateral, like the angle HD And the angle at B, the angle here is some different ink. The angle here and the angle at D are supposed to be supplementary in that they add up to 180. So when we take 180 and we subtract 58, we should be able to get the angle at B. And this becomes 122. Now, if this is 122, then we can get the base angles for ABC as a triangle, because we need to take 58 and we divide it by 2 for us to get here 59 and here 29, 29, sorry. When we take 58 divided by 2, we get 59, yeah. So 29, that is 29, 29, because AB and BC are equal. So the base angles are supposed to be equal, and they are equal to 58 divided by 2, 29 each. So that inside this particular triangle now, we can get a sum of 180. Now, when the angle at A is known, we can easily get the angle at C. When the angle at C is known, we can still get the angle BCS. So we can say that the angle at A has been produced by the chord. Look at it this way. It has been produced by the chord CB. So CB produces the angle at A, and the same chord CB is making an angle with a tangent. Therefore, those angles are supposed to be equal. Therefore, the angle is the same as the angle at A, which is angle BAC, which is equal to 29. Angle made by what you call tangent, and a chord is equal to angle in the alternate segment. Angle in the alternate segment, that way. Then after getting the angles now, we see part B, which says calculate to 2 decimal places the lengths AC. We start with length AC first. For us to get length AC, we can follow several approaches. In this way, the diameter is already known to be, is it 28? Yeah, 28 centimeters. 28 centimeters. Now that we know the diameter there, we need to work with a triangle. And in this case, we can talk about triangle DAC. With triangle DAC, which is right angled at D. Right angled at D. Then we can apply trigonometry, because we can't use Pythagoras theorem because it is only one length which is known, that is AD. So we use trigonometry, whereby we say, let me sketch let me bring the triangle out here. Let me bring the triangle out here. I want to extract it. So we have yeah, the triangle here, right angled at C. This is A, this is D. The angle here is 58. The angle here is 32. The length here is 28. So we can use either, which length do we want? This one. It is length AC needed. So we can use either sine or cosine. We can't use the tangent because none of the short angles is given. The short sides are not provided. So we talk about if we use cosine, we shall apply 32. If we use sine, we shall apply 58. It's high time for you to remember that the sine of 32 will be equal to the cosine of 58. The sine of 58 will be equal to the cosine of 32, because they are, call them complementary angles. They add up to 90. So sine of one equals to the cosine of the other. So we can use any of those ratios. So when we apply sine, we say sine 58 equals to opposite length. The sine of 58 equals to opposite length out of the hypotenuse that way. That means for us to get the x, we need 28 sine 58. So 28 sine 58. This gives us 23.75 centimeters. This one is to 2 decimal places. Then the other length is AB. So let's look at length AB. For length AB now, remember AB and CB are equal according to the diagram and the instructions which have been earlier provided. So we can bisect the triangle into 2 equal triangles. Then the length known in this case is length, assuming that this is point X. So length AX can be found because we have AC, then we can get AX. Then we shall be using a triangle now, which is like this. Be using a triangle like this. If this is point A, this is X, then this is B. Remember, we want AB, and AX can be calculated by taking the average of AC. So that will be 11.87. 11.87. And the angles now, the one at A is known to be 29. That way. So it's right angled at this point. So we can get the length on the other side. We will apply cosine. The cosine of 29 degrees equals to cosine of 29 degrees equals to the cos of 29 is equivalent to adjacent length 11.87 divided by hypotenuse, which is unknown. So how do we get this hypotenuse called X? It will be 11.89 over the cosine of 29. So when we divide this by cosine of 29, we'll be getting 13.57 degrees. Oh, okay, centimeters, sorry. Now, we have already calculated now the angles and the lengths which the examiner demanded. So we are done with that. Now we'll be talking about another question, which is number 23, question on geometry together with LOCI. So we're supposed to be very keen again when interpreting this problem using a ruler and a pair of compasses only. That means without using a protractor. Construct a parallelogram PQRS such that PQ equals to 10 centimeters, QR 5.8 centimeters, and the angle PQR equals to 82.5 degrees. So let's work out this. The first thing that we're going to do, we will measure Q, which is a PQ, which is 10 centimeters. So let's do the 10 centimeters first. So if I name this one my P, then I have to measure. I'm supposed to measure 10 centimeters for me to arrive at Q. Then now it is at Q where we're supposed to construct the 82.5. Something very interesting is that there are some special angles which can be constructed with a ruler and a pair of compasses without the use of the protractor which measures angles. So you're supposed to, when you are given a different angle now, you should ask yourself, how is it related to the angles that you can measure, that you can construct directly? How is it related to the angles that you can construct? For example, 82.5 is the half of 82.5 multiplied by 2. This gives us 165. 165. And you see, with 180, when 15 is constructed here, the remaining angle is going to be 165 automatically. Therefore, we will be bisecting now the 165 to get exactly 82.5. So that is the knowledge that we're going to apply in this case. Yeah, that is what we shall apply. So now we get to the construction of 15 first. Construction of 15. We begin with the 60. So we're going to construct 60 at this point. So to construct 60 without a protractor, you stand at Q and you make an arc. Then standing on that arc, you cut the first arc on the upper side. This is going to give us 60 degrees. Then now we're supposed to stand on these arcs to bisect the 60 until we get 30 degrees, because the half of 60 is 30. So we make an arc, and standing on the other arc, we make another arc to cut the first one. This means we are now having an angle of 15 degrees. Then after that, we are supposed to bisect the 30 to get 15. We bisect 30 to obtain 15. So when we bisect 30 to obtain 15, now we will remain, let me bisect that. So I stand on these arcs, we make an arc, then we make an arc again. When we join here, we will be having our 15 degrees. So that is equal to 15. If that is 15 now, the whole of the angle, this one now, the whole of this angle, the whole of that angle, this one marked with red, the whole of that angle is 165. Now, when 165 is bisected, we are supposed to get 82.5. 82.5. So that is what we want. 82.5. Therefore, we stand here, we make an arc, then we make another arc here. Then standing on those arcs, we're supposed to make an arc and an arc, such that now when we connect those arcs to Q, we shall have 165 bisected that way. So we are having now 82.5 degrees that way. 82.5 degrees. Yeah, very good construction of 82.5. You must use your brain in this particular case now. All right. Once that is done, now we are supposed to measure along this line now. We measure a length of, because we want QR now, 5.8. So 5.8 shall be at this point, 5.8, that way. This becomes R. Now, after that, 3 points have already been identified in this parallelogram. 3 points are already identified. So with 3 points already, then it means we can use the radius of 5.8. We stand at P and we make an arc. With the radius of 5.8, we're supposed to stand at P. We make an arc. Yeah, that way. Stand at P. We make an arc. Then we stand at R using using 10 centimeters. Using 10 centimeters, then the intersection of 10, the intersection of 10 and 5.8 is going to give us, it's going to give us our point S. So we join the point S like that. Let me make it more accurate. So when we stand at P, we are using 5.8. We're supposed to make an arc. Supposed to make an arc. Then standing at R, we use 10 and we make an arc that way. So we can now connect that point of intersection. Yeah. Then now we can use a ruler to join the new point identified with R. This is supposed to be our S now. So PQRS is a parallelogram perfectly constructed without the use of a protractor, without the involvement of a protractor. Now let's get to more questions about the same. On the diagram, locate the locus A such that from Q to A is greater than from A to R. So we're going to translate the inequality into an equal sign first. QA equals to AR, so that we may know the borderline to be used, but you know that the borderline will be dotted because this one will be dotted to be a dotted borderline. A dotted borderline shall be dotted. In case it was this way, we would have used a complete line. But now that it is just greater than strictly, we use a dotted line. Okay. So now to interpret this now, it means A is going to be the bisector. A is going to be the bisector of QR, actually perpendicular bisector for this case. So that from Q to A and A to R, the distance is the same. So we bisect perpendicularly. We bisect perpendicularly the distance from Q to R. We bisect it perpendicularly. Therefore, the first thing is to identify the mid. Then we bisect perpendicularly. To bisect perpendicularly, remember we are not supposed to use a protractor. Therefore, we just need to stand at Q. Standing at Q, we make arcs. We make an arc here and an arc here. Then standing at R, we cut those arcs. Now, when we join the intersection of those arcs, we will be able to get the perpendicular bisector. And it's supposed to be dotted. Remember that? It's supposed to be dotted. So let me be very careful in the coming up of that bisector. It's supposed to be dotted. Supposed to be dotted that way. So this is going to be the locus of A. Supposed to be dotted. Allow me shed later after we've come up with all the loci, depending on the instructions here. So we go to B now. We need the locus of B such that the area of PBQ is greater than or equal to 17.5. So PBQ is supposed to be a triangle such that the height of this triangle can be calculated because from P to Q is already 10. This is 10 centimeters. So we need a point, B such that the area is going to be 17.5. So we use area being 17.5 given by half times a base of 10 times a known height. This is 5. When we divide through by 5, we get 3.5 being the value of h. Therefore, now we're going to draw parallel lines to PQ such that this line is going to be 3.5 centimeters away. 3.5 centimeters away. So we're going to measure 3.5 from P and Q. 3.5 from P and Q. 3.5 from P and Q. This way, then between the two, that will be our B. Remember, it's supposed to be a complete line for this case. Supposed to be a complete line. So this is supposed to be our B. Yeah, that way. That's supposed to be our B. In case we produce a triangle from PQ to the line, to any point along that line that you have called B, the area of that triangle is supposed to be 17.5 because it will have a perpendicular height. It shall have a perpendicular height of 3.5. Yeah, 3.5. That way. All right. The next one, the locus of C. And this way, it is supposed to be the angle PCS equals to 120. This is called the constant angle loci. And how do we construct it? This time around, you see, it's an angle which is not acute. Therefore, to construct 120, using a PS, as the chord, we need to obtain 120 here. So for us to get 120, or for us to get a circle locus, whereby we can subtend 120, we need to construct, okay, for PS to be able to subtend 120, it means it should be in a position to subtend the supplementary angle, which is 60 on the opposite side. Now, for us to subtend 60 on the opposite side, we should be having a center where we can subtend 120. And for us to subtend 120 at the center, then we should be having base angles, which are equivalent to 30. Base angles equivalent to 30. So we are going to use PS as the chord, and we need base angles equivalent to 30. So we need to construct 60 first. We need to construct 60 first. Remember, all this should be done without a protractor. All this should be done without a protractor. Therefore, and it's good for you to remember that you guys can register to our programs, whereby we're going to discuss all this one-on-one. Therefore, at this point, I'm supposed to stand at S, and I make an arc. Then standing on this arc, I cut the first one such that I be able to produce an angle equivalent to 60 degrees. If that angle is 60 degrees, then I'm supposed to bisect it. So that after bisecting it now, I get 30 degrees. So I bisect the 60 like that for me to get 30 degrees. Yeah, so this is exactly 30. So after that, I'm supposed to construct another 30, still without a protractor on the opposite side, so that the intersection of the two angles of 30, the intersection of the two angles of 30 will give us a center in such a way that standing at the center, operating from this center now, we should be in a position to produce an angle of 60, then another angle of exactly 120 in the alternate segments. Therefore, using that center, this is supposed to be our C now. This is supposed to be our C. So that is C, we have B, and we have C. So when you examine these very well, you will be discovering that the locus of C, B, and A are bounding a common region. That is why we have the instructions. That's why we have the instructions in the last part, whereby we are told now to shade T, the region that is defined by the locus A, B, and C. So the region bounded by all of them now. Let me shade it for you. Should be able to observe it. Okay, let me use a different color here. So the region T is going to be this one now, bounded by all the loci. This is the region T now, which has been bounded by all the loci. So these are going to be our region T. We name it T. So anywhere there is our region T. Should be in a position to come up with a diagram like that. Like that. So remember that our consultation line is 0704153366. That way. So you can reach out for the individualized programs. Now, the last question, which is number 24. The table below shows some values of the function y equals to a, the cosine of x minus 15, and y equals to b, the sine of x plus 50, for the range of x between 0 and 150. So you can see some values have been provided. Then the question is asking us to determine the value of a and b. All right, now that we are given some values of y, like 2 in the first function, we have 2 provided. So 2 is here. So how is 2 obtained? 2 is given by, 2 is the value of y. So it's given by a, the cosine of x, which is 15, minus 15. So this is going to be 2 equals to a, the cosine of 0. The value of cos 0 is 1. So 2 equals to a multiplied by 1, which means the value of a is 2. So for a, we have gotten the value, it's 2. And that should be able to lead us into concluding that the first function is supposed to be y equals to 2 cosine of x minus 15. That is the first function. Now, the second function, whereby the value of y is given by b sine x plus 50, and one of the provided values are here. We can even use a half. Any value can be used. So half equals to b, the sine of x plus 50. And what is x for this particular case? X is 120. So x is 120. So we need 0.5 equals to b sine of 170. So for us to get b, we need 0.5 divided by sine 170. And that becomes 2.88 to 2 decimal places. So it means that the second function is y equals to 2.88 the sine of x plus 50. So that is now, we are now having the, I've just made the work easier by giving the values of the functions. But basically what we needed are the values of A, the values of B. Now look at part B, complete the table now. Now that you have known the values of A and B, we can complete the tables. So let me go to the first value for the first function. So the value of y will be given by A, which is 2, the cosine of 0 minus 15. And that will give us 1.9. And I'll use 1 decimal place because the other values have been given to 1 decimal place, so 1.9. Then at 30, we talk about 2, the cosine of 30 minus 15. This will give us 1.9 again. Then we go to 45, whereby we need 2 cosine of 45 minus 15. There we'll get 1.73, so 1.7. Then at 60, it will be 2, the cosine of 60 minus 15, giving us exactly 1.4. Then at 90, we talk about 2 cos 90 minus 15. This will give us 0.5. Then at 105, it will be 2 cos 105 minus 15. This will give us exactly 0. Then at 120, it will be 2 cos 120 minus 15. And this will give us negative 0.5. Then we have at 150, whereby it will be 2, the cosine of 150 minus 15, giving us negative 1.4. Yeah, negative 1.4 that way. Then for the second function now, we'll be having the second function is here. So it is 2.88 sine, we open brackets for 0 plus 50 for the first value. And I'm getting 2.2. And when you round off to 1 decimal place, you get what we're having here. Then I go again to 2.88, the sine of x is 15, then plus 50. That will give us 2.6. Then we go to 30, 2.88 sine 30 plus 50, giving us 2.8. Then we go to 45, whereby 2.88, the sine of 45 plus 50, giving us 2.9. Remember, I'm just feeding into my calculator the functions. The value of x is being read from the table. The others are all constants. So in the next value, I'll be writing 2.88, then sine, I open brackets. The value of x is 60 plus 50. So now I'm getting 2.7. Yeah, 2.7. Then we go to 75, whereby I'll start with 2.88 sine 75 plus 50. I'm getting 2.4. Then at 90, it's already given. We go to 105. So 2.88 sine 105 plus 50. I'm getting 1.2. Then we skip, we go to 135. So 2.88 sine 135 plus 50. This is giving me negative 0.3. negative 0.3 that way. Then at 150, 2.88 sine 150 plus 50. This will give us negative 1.0. Yeah, negative 1.0. So we having now all the values. The tables have been filled. So we have to go to the second part of this, or the third part, whereby we are told on the grid provided and on the same axis, draw the graphs of y equals to a cosine of x minus 15 and y equals to b the sine of x plus 50 for the range of x between 0 and 150. So we're going to do this one now. Let me begin by doing the Cartesian plane, whereby I draw the y-axis that way and the x-axis. So let me look at the values for x-axis. The values for x-axis, yeah, I can see them. Then the values of y, we have all the way from negative 1.4 all the way to 2.9. So we need bigger values to be positive for y. So these are the y-axis. The y-axis, the x-axis, 0, 15, because we've been told to use a scale of 1 centimeter for 15 degrees on the x-axis, 30, 45, 60, 75, 90, 105. Then when we add 15, we go to 120, 135, 150, 165, like that. Then on the other axis, we are told to use a scale of 1 unit, 2 centimeters for 1 unit. So 2 centimeters for 1 unit means these are 0.5, then 1 unit after 2 squares. Like that. So we have labeled our axis very well. Now we can go to the plotting now. The first function first. So the first function is y equals to a cosine of x minus 15. So 0, 1.9. 0, 1.9. 1.9 shall be at this point that way. Then at 15, we go to 2. 15, go to 2. Then at 30, we go to 1.9. Then at 45, we go to 1.7, 1.5, 0.6, 0.7 there. Then at 60, we are talking of 1.4. At 60, 1.4, which is just below 1.5. At 75, 1.0, which is here, 1.0. Will be very accurate. 1.0 there. At 90, we are talking of 0.5. Then at 105, we are talking of 0 exactly. At 120, we are having negative 0.5. So negative 0.5 shall be here. At 135, we are talking of negative 1. Then finally, at 150, we are talking about negative 1.4. So negative 1.4 shall be here. Negative 1.4 shall be there. So this is the curve that we're supposed to come up with. Let me use this ink, which is a blue. Curve is supposed to be continuous. Curve is supposed to be continuous. So let's observe easy. We are coming up with a very smooth curve. Yeah, that way. That is the first curve. That is the first curve. Then now we can check the second curve by first of all plotting the coordinates. So the coordinates are going to be at 0, 2.3. So 2.3 is somewhere here below 2.5. Then at 15, 2.6. 2.6 is slightly above 2.5. Yeah. Then at 30, we are talking about 2.8. 32.8, which is below 30. Then at 45, 2.9. At 45, 2.9, slightly below 3. Then at 60, we are talking of, at 60, we are talking about 2.7. At 60, 2.7, is at a point like that one. Then we can also talk about at 75, 2.4. 2.4. Then we can also talk about at 90, 1.9. At 90, 1.9, slightly below 2, 1.9 there. At 105, 1.2. So 1.2, which is here. At 120, we are talking about 0.5, which is this value. At 135, we are talking about negative 0.3. So negative 0.3 shall be found here. Then at 150, we are having negative 1. Negative 1 that way. So we draw the second curve. We draw the second curve. Let me use a different color here. Red. Yeah. So again, we're supposed to come up with a very smooth curve. That way. So we are having the two curves here. Yeah, we are having the two curves there. And now we can go to the last question. Yeah, the last part. This. The last part of this. Sorry. I don't know what's happening in this. I don't know what is happening here. But anyway, the other thing that had remained is just a answering of, yeah, here it is. Thank you. It's back. It's back. Use your graph to solve A, cosine of x minus 15, minus B, the sine of x plus 30, equals to 0. You see now there is an error in that typing because we don't have x minus 30. But now, assuming that this was x plus 50, then we can say we need a cosine of x minus 15. the negative b is taken to the other side, whereby it becomes positive now. I'm just assuming that they made an error here. Yeah, just assuming that they made an error. So this means we should look at the points where the two curves are interacting. And for this, for the limited scale that you've been given, the curves are not intersecting anywhere. Therefore, no real values, because the two curves have not met anywhere. So that is how we end it. This is the last page. You can follow us 0704 15 33 66. So thank you so much. See you next time.